guys, Tor here from Overlook Horizon, and welcome back to another launch day today for SpaceX's Starlink satellites. This is going to be Starlink launch 28. We've had quite a few of these over the last year and a half or so, and we're getting a couple more up there today. Another 60 satellites launching into low Earth orbit today for SpaceX's Starlink constellation. That's their high-speed internet service that they're trying to cover the whole world with. And actually, after today's launch, this will be the completion of what they're calling the first shell of satellites. So this is actually kind of exciting. We're getting to that completion of the first shell of satellites, which will provide coverage to 80% of the world with this first shell. Now there are, I think, 5 shells total. Basically, these are different altitudes, different inclinations. They're kind of all over the place to make sure that the entire globe is covered. So Shell 1 will be completed after this launch here. Then they'll move on to Shell 2, which is a slightly lower altitude, same inclination, roughly the same inclination. Shell 3 actually moves on to a 70-degree inclination, and then Shell 4 and Shell 5, those are our polar orbiting inclinations at like 97-degree inclinations. That's when we'll get actual polar orbiting satellites. But we're not there yet. We've got a long ways to go to get there. Right now we're at about, I think, like 1,600 or so satellites that have been launched. I can tell you the exact number here in just a second, but yeah, it's about 1,600 satellites that they have in low Earth orbit for this constellation here. Let's see, currently 1,677, that's what's been launched. Currently active is 1,578, 1,578 currently active. So there have been a couple of satellites that have deorbited. It's gonna deorbit based on them failing to operate or being decommissioned. But we're at about, what did I say, 1578, so just under 1,600 active satellites, but they've launched 1,677 now. There's a lot of satellites. So 1,677, the goal here for phase 1 of Starlink satellites is to get up to, I think, 4,500. Checks notes. What did I say? The goal phase 1 is, let's see, I can tell you the exact number if I can find it in my notes. I know I have it here because I was just looking at it. Well, phase 2, 7,518 satellites. Phase 1, there it is, 4,408 satellites as part of phase 1. So we're only at 1,677 that they've launched. 4,408 is phase 1. Then an additional 7,518 for phase 2. But that's coming years down the road. So anyways, that's what's in store here for today. So in case you're watching the replay, now that we've done all that, I figured I added something new. I added the current date and time right here, because a lot of people, sometimes people watch the replay and they yell at me in the comments. They're like, "This isn't live. This happened yesterday." It's like, well, it was live yesterday. So here's the date and time, just in case you're watching the replay, and I'll put timestamps below if you want to skip ahead. But if you're here with me live, no skipping ahead at the moment. Wouldn't that be nice if we could do that? We're 24 minutes to launch, so you gotta wait 24 minutes if you want to watch it today with me. So, fueling is underway for the Falcon 9 rocket. The launch director gave the go for propellant loading. That's the RP-1 rocket-grade kerosene and the liquid oxygen, super chilled to negative 340 degrees Fahrenheit, I think is the temperature. Very, very cold. That's part of the benefit, the competitive edge for SpaceX. I don't know what I'm trying to say, but the super cold fuels there allow them to load it in, launch right away. They generally have a launch window for Starlink launches, but the launch window is only like 20 minutes. So now that they've committed to fuel loading, now it has turned into an instantaneous launch window because they don't have enough time to recycle the count once they start fueling, because they would have to refuel the rocket. They can't just let it sit there with fuel on the vehicle for extended periods of time because that liquid oxygen and even the kerosene warms up, gets to, you don't get the density of fuels in the rocket anymore, and so you're not going to be able to hit your mission parameters. So, all right, let's check in with the comments. I see the comments flying by. Let's see, say hello to everybody, see who's here with us. We scroll back a whole bunch. Saw a bunch of comments flying by over on, we got them all. Facebook, Periscope, YouTube. Everybody's here. Dave Thompson over on Facebook says, do you think we'll be getting any space mice this time? I think there's a good chance we might see it, especially daytime launch, easier to see. What time is liftoff? 22 minutes from now. All systems are go, says Andrea, which is true. We're in good shape. Let's see. No SpaceX shirt today, says Robert. No, I didn't wear the SpaceX shirt today. I don't know why. This is what I wore to work today. So this is what I'm wearing today. Usually I do try to throw a SpaceX shirt on, but not today. Planet Musk Vlog says, that Starbase sign though. I know. Did you see the new Starbase sign over in Boca Chica? They put out a brand new gigantic lighted letters that say Starbase right outside the is it outside the launch pad, or is it the build site? I need to get down there one of these days. I think it's outside the launch pad, isn't it? Now I don't know. Now I'm questioning it. But anyways, it's in Boca Chica. It's huge. It's a Starbase. It looks kind of awesome. Let's see. We're gonna go through a couple more comments here. Any liquid hydrogen stages today, says Apple and Banana. Apple and Banana, no, there's no liquid hydrogen today. This is RP1 rocket grade kerosene and liquid oxygen. Lots of launches to watch. Yeah, we do have a couple coming up. We've also got a CRS mission coming up here in a couple of days. That's commercial resupply services for the International Space Station. That's going on the new Crew Dragon 2. Or Cargo Dragon 2, I always screw that up. Cargo Dragon 2, that's going to be sending up supplies to the International Space Station. That's coming up in like a week. Let's see, what happened to Rocket Lab? Well, I don't think we really know the full story yet. They were investigating. I think we'll probably hear more soon, but they're still in the midst of an investigation as to what happened to Rocket Lab. So Fabrizio says, ciao Tori, ciao Fabrizio, come stai? Come stai oggi? Let's see, when will the planet be covered by satellites? So SpaceX has until I think 2027 for phase 2. Hold on. There's so many dates. I gotta check my notes. I got notes here for Starlink. So, they have phase 1 has to be halfway completed by March 2024. Has to be fully completed by March 2027. Phase 2 has to be halfway complete by November 2024 and fully complete by November 2027. Otherwise, they would risk losing the frequency allocation that they have from the FCC for their satellites. So they have they got to get those up in order to do that. Hey, look at my little lobster that keeps jumping up is alive today. That's interesting. I have maybe I'll hide the date and time for now. I have tried for weeks to get this little lobster to pop up and show subscribers, but for the life of me, this would not work. Like, I set this up like months ago, and it would not, but all of a sudden, it has come to life today. So, hello, lobster. Well, thanks for joining the party today. I don't know why it didn't want to work before. All right, let's talk about... let's see. Is there a limit to the amount of satellites to put into orbit? Well, you're talking like for Starlink, for SpaceX, or like total? Like total limit is going to be huge, right? If you think about, we talk about this every time. Like at any given time, let's see. I always forget what the number is. At any given time, there are thousands, what is it? There's an average of 10,000 airplanes in the air at any given time. So at any given time, you can look up in the sky and there are 10,000 airplanes flying around. But when you look up in the sky, like, unless you're sitting on the approach path for JFK Airport in New York City, like, you're probably not seeing that many airplanes. You know, maybe if you're the approach path of insert whatever large airport is near you, you'll see a whole bunch. But for the most part, nobody's looking up in the sky and being like, oh my goodness, there are so many planes up there. And that's 10,000 planes at any time. Sometimes more than that. That's just the average. So there's plenty of space up there, right? Space is huge. So we've got lots of room to move. Like SpaceX is talking about phase 1 and phase 2 is about 12,000 satellites they're trying to put up. They've even talked about going beyond that up to like 40,000 satellites. And I think you would still have plenty of room even at 40,000 satellites. It does become a logistics nightmare trying to track all of those satellites. That's a problem. That's something that we got to make sure that we're keeping track of. You also, the big problem with this really is night sky astronomy. Studying stars, galaxies, things. We do a lot of that here on the ground. Amateurs do it for photos and things like that, but we do have research stations that do it here as well, and observatories. And those satellites can be problematic, so we got to figure out a way to deal with that as well, which SpaceX is trying to do. So, Randy over on Facebook says the lobster was being crabby. That's why it didn't want to work. All right. Let's see. Did you see that Viasat filed with the FCC to try to stop Starlink because it will put them out of business? I did see that Viasat filed a complaint to try to stop Starlink from launching. They're trying to get an injunction against them to stop their satellites. Let's see. Pete Richards says, shouldn't you edit the intro video to show the Starship landing successful-ish? I've thought about it, but I kind of like the big boom at the end. I feel like it's a nice closure to the intro. All right, let's talk before I run out of time, because SpaceX is going to be live here. Oh, they're already live. Well, they're not talking yet, so while we're waiting, I will let's talk about our things here real quick. We're gonna do the speed run here, real fast as we can. All right, so here's our trajectory here today. We're launching from Cape Canaveral. This is the Cape Canaveral Space Force Station, Space Launch Complex 40 down here, the smaller of SpaceX's 2 pads. Their other one is up here, 39A, the big one. That's where they launch Falcon Heavy and Crew Dragon from. But we're heading to the northeast. We'll be under powered flight. Separation event right here, the first and second stage. First stage is reused. Second time this first stage is flown. Kind of a baby first stage, to be honest, by today's standards. But that will come back and land on the drone ship. Second stage will continue on. Payload fairings will be jettisoned. One of the payload fairings has already flown 4 times. So this is the 5th flight for it. That's one half of it. The other half, I think, has flown once before. But I know the old one, the veteran, has flown 4 times. That will come back. They're going to, I believe they're going to pull them out of the water after a soft landing. They have done away with the net. The Mr. Steven, Miss Tree, Miss Chief nets. Those are gone. They're not doing them anymore. So they're just landing them in the water and then plucking them out of the water. So we're going on to about a 52, 53 degree inclination here. That's this orbital path that we see right here. And that's what we have in store. This is courtesy of flightclub.io. If you want to run your own simulations, go check out flightclub.io for just about any launch. And what we're launching, like we said, this is the Starlink constellation here. This is what we've already got in orbit. This is the web that has been woven by SpaceX of Starlink satellites, all covering the globe. We got really nothing. There's only 10 satellites on one path here that are covering the poles, north and south poles. So don't have a lot there, but we've got a ton in the main shell here. So this is going to complete the main shell here today, and that's going to give high-speed internet service. Weather today, I'm racing SpaceX here. Weather today looking pretty good. This is your weather report with Tori. We've got, let me switch to a measurement that I actually know. 10 mile per hour ground level winds, which is, what is that? 15 kilometer per hour ground level winds. So looking really good there. Satellites really showing nothing of concern. And then our upper level winds, they're not really much either. 35 kilometer per hour upper level winds, which is, give me miles per hour for our American friends. 22 mile per hour upper level winds, which is actually kind of slow for upper level winds. So nothing too crazy. The 40, well, they were the 45th Space Wing. Now they're called something else, and I can't remember what they're going to be called now. But they're giving a 10% chance of violating launch constraints with cumulus clouds, the main factor. I don't think it's going to be a factor today. I think we're in great shape. So, all right, SpaceX is live. They're chatting. Let's bring them up and let's see what's happening here today. And we'll listen in, and I'll get my clock to match their clock so they're on the same time frame here.
If you've been following Starlink's progress, you'll know that our Starlink beta service is now available in the United States, Canada, New Zealand, Australia, and several locations around Europe. We're excited to announce that service is now also available in Belgium and the Netherlands. To date, over 500,000 people have placed an order or put down a deposit for Starlink, and with every launch, we get closer to connecting.
Oh, I need my window back because I got the wrong. Oh, wait, what is this? What happened here? Hold on. I need this window back. One moment. Here we go. Okay.
Coverage of the populated world. As always, head over to starlink.com to learn more. We are now at T-minus 11 and a half minutes, and all systems are still go for an on-time liftoff at 2:59 p.m. Eastern Time. With that, let's take a closer look at the rocket that you see on your screen.
Hello, I'm Shiva Bharadwaj, a space operations engineer. Now the Falcon 9 on your screen, that's our two-stage liquid-fueled rocket, has been loading propellants since T-minus 35 minutes. Falcon 9 stands 229 feet tall. That's slightly taller than a 21-story building. And much different from our recent Starlink missions, which launched and landed boosters for an 8th, 9th, and even a record-breaking 10th time. The booster that we're flying today is fairly new, having only supported the Sentinel-6A mission last year. Now, the bottom two-thirds of the vehicle is the first stage. You can see some of the soot left over from its previous flight. The first stage accelerates the vehicle through the Earth's atmosphere into space with the help of 9 Merlin engines that it has at its base. As I mentioned, we will be attempting to recover this first stage for the second time on our drone ship named Just Read the Instructions. On top of the first stage, we have our black carbon fiber inner stage, and on top of that is Falcon 9's second stage, which has a single Merlin vacuum or MVAC engine. Once the first and second stages separate, about 2.5 minutes into the mission, the Merlin vacuum engine will ignite and carry our 60 Starlink satellites into an elliptical orbit around planet Earth. Now, you'll also notice this large nose cone at the top of the rocket. That's called a fairing. That's where the stack of Starlink satellites is safely enclosed. The fairing's job is to protect those satellites from aerothermal heating, aerodynamic loads, and contamination during the ascent phase. Once we reach the vacuum of space, we'll jettison those fairing halves as the second stage continues on its journey to orbit. The fairing halves protecting our Starlink payload have quite a history. This will be the first fifth flight for one of the halves. Before today's launch, that half supported 4 previous Starlink missions going back to 2019. The other fairing half will be flying for the third time, previously having supported the Transporter 1 and Starlink 21 missions. Now, today's flight also marks the 40th time SpaceX has reflown fairing halves since November 2019. And of course, we're going to be attempting to recover them today using our recovery vessels named Go Searcher and Go Navigator. Beautiful day at the Cape. Weather is forecast 90% favorable for liftoff, and the recovery conditions look quite good for the booster. So with that, the vehicle, satellites, weather, and range are all looking good for an on-time liftoff just a few minutes from now. Now, for some reason, we do not launch today. We do have a backup opportunity available tomorrow at 2:38 p.m. Eastern Time.
Now that you know a little about the structure of Falcon 9 and its engines, the propellant, which is a substance used to create the energy to make the rocket go. Falcon 9 is a bipropellant vehicle, meaning it uses two propellants, a fuel and an oxidizer. An oxidizer is a type of chemical which a fuel requires to burn. Most burning on Earth uses oxygen, which is prevalent in the atmosphere. However, in space, there's no atmosphere to provide oxygen or other oxidizers, so rockets need to carry them up on their own. For Falcon 9, our fuel is a refined form of kerosene known as RP1, and our oxidizer is a super chilled liquid oxygen called LOX. The liquid oxygen is chilled well below its boiling point so that it becomes what we call densified, which means there is a much greater amount of mass per volume, and we can load more of it into the booster. In addition to its propellants, Falcon 9 also needs an ignition source in order to go. And for that, we use the chemical TTEB, or triethyl aluminum and triethyl borane. When it is fully fueled, Falcon 9 holds just over 1 million pounds of propellant that the vehicle will burn through in less than 3 minutes after liftoff. Once our Merlin engines begin to burn RP1 kerosene and liquid oxygen, you'll see the rocket throwing the exhaust out of the engine bells in one direction while pushing the rocket in the other. This is a great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. That 1 million pound weight of propellant is turned into all the flames that you see in flight coming out of the engines, creating the almost 2 million pounds of force exerted on the rocket to lift it up.
Now, in order to get to space, the rocket has to do more than just go up. It also has to go sideways really, really fast. At liftoff, gravity is pulling straight down on the rocket. But as we ascend, we'll start to tilt the engines, which is technically referred to as gimbaling. That turns the rocket horizontally. We're still going up, but we're also now heading horizontally away from the launch pad, and that maneuver is referred to as a gravity turn. The rocket typically needs to get to about 7.5 kilometers per second, or about 17,500 miles an hour horizontally in order to avoid being pulled back down to Earth and to get into orbit. To help demonstrate the concept, imagine we were firing a cannon from a really high mountain. The cannonball will arc, and then gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land further and further away. Eventually, you could continue to increase the power, and the cannonball will go so fast that it ends up in free fall around the Earth. Gravity's still pulling on it, but it's going so fast that it never hits the ground. This arc that constantly misses the Earth is what we call an orbit.
New graphics.
When we get to liftoff today, keep an eye out on the orientation of Falcon 9. You'll see it initially start to go straight up until about T plus 10 seconds, at which point we'll start to shift orientation so Falcon 9 can start picking up sideways velocity. But before we get to that, why don't we check in on the status of the vehicle for today's launch?
We are currently just under T-minus 5 minutes and 30 seconds from liftoff, and Falcon 9 is now moving into the final stages of the countdown. We are currently waiting for the transporter erector, or TE, to retract, and that's that truss structure right next to the vehicle. First, the TE clamps will open, and the transporter erector will then begin to retract away from the rocket slightly, and at T0, hydraulics will pull the TE farther away from Falcon 9 as it lifts off. Now, the TE provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing.
Tanks pressing for strong back retract.
So that strong back
now,
retract.
Those clamp arms that you can see just below the fairing should start to open soon, and strong back retraction should happen in just a few seconds here.
Yeah, so right around 4 minutes is when they start that process. We'll see should see the clamps open right around 4 minutes.
Strong back lever started.
You heard strong back has started to retract. You can see those clamp arms opening around the Falcon's second stage there.
Saw a couple super chats come in. I did want to say thanks here because I saw Graham, one of our moderators,
You can see that strong back.
said this is the best job I've ever paid for. Thanks, Graham, for your help there. And Dana's going to post a time lapse. Dana's from down there in Florida. Was going to post a time lapse in Discord later. So join our Discord to see Dana's time lapse.
Fuel and liquid oxygen. Super chilled liquid oxygen is our propellant oxidizer, and that is what you see creating those white clouds that you can see around Falcon 9 there. And that's because the warm, humid ambient air causes the liquid oxygen to turn into a gas around the booster. Now, first stage should finish prop loading at T-minus 3 minutes, just under 10 seconds here. And the second stage will finish prop loading about a minute after that at T-minus 2 minutes.
Poco bleed.
At T-minus 60 seconds, Falcon
Stage
9...
1 lock slow, close out.
Falcon 9 will be in startup, and you heard that call out for stage 1 LOX load complete. And when Falcon 9 gets in startup at T-minus 60 seconds, this means that the rocket's autonomous internal flight computers have taken control of the launch countdown. And just inside of T-minus 2 seconds, we light the Merlin 1D engines using that T-type ignition source we talked about, and we're set to lift off. The Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking favorable, and the range is green for launch. So here at just over T-minus 2 minutes, let's listen in on the terminal countdown.
So we're going to see one final big vent coming in about a minute and 35 seconds. That's when they're going to drain all the liquids out of that transporter erector, all the fuel lines there. They're going to drain those starting right about a minute and 35 seconds.
Stage 2 lock slow, close out.
Framrick, another
We
one.
have just finished loading our second stage. Our Falcon 9 is now fully loaded with over 1 million pounds of kerosene, RP1, and liquid oxygen.
Framrick, thanks
Again,
for the
that
super
white
chat there.
cloud coming from the booster there towards the middle is normal and expected. That is venting from the TE LOX line.
There you go. There's that big venting right there. Ooh, we got Pat.
Again, at T-minus 1 minute, Falcon 9 will go into startup, and this is when stage 1 and stage 2 will begin pressurizing for launch, and the flight computer will have taken control of the countdown.
We got those pad mics going. Can't wait. Framrick said, missed the launches during night shifts. Great to watch.
Startup.
Glad to have you
Falcon
here.
9 is in startup, and in just a few seconds, the launch director should give the final go for launch.
Here we go. Hopefully they get those pad mics cranked up.
Stage 2 pressing for flight.
Falcon 9, Starlink LDs go for launch.
You heard that call out for go for launch. All systems are go.
T-minus 30 seconds.
Let's listen in to the terminal count and watch as Falcon 9 takes our Starlink satellites to orbit.
Give me a go, no go in chat. Is the chat ready? And this is your headphone warning, because it's probably going to be loud.
T-minus 15 seconds.
Stage 1 pressing for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And liftoff.
Vehicle is pitching downrange.
Look at that view.
Stage 1 propulsion is nominal.
See a little roll program there. It's a cool view.
What a beautiful day for a rocket launch here. As you can see, Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Space Force Station, carrying our stack of 60 Starlink satellites to orbit. Moments ago, we throttled the engines down in preparation for max Q, or the maximum aerodynamic pressure that the rocket
Vehicle
will
is
see.
supersonic.
Vehicle is supersonic, and we should be passing through max Q here in just a few seconds.
Saw that little
Vehicle has reached maximum aerodynamic pressure.
We just passed through max Q, and in about a minute, we will have 3 events happening back to back, and that's main engine cutoff, or MECO, stage separation, and second engine start 1. So first, main engine cutoff. That is where all 9 Merlin 1D engines that you can see burning right now will shut off to slow the vehicle down in preparation for stage separation. And this is where the first stage separates from the second
Game
stage.
control has begun.
With the first stage making its way back to land on our drone ship, just read the instructions, while second stage continues on its journey to its third event, which is second engine startup 1. Now this is where the 1 MVAC engine on our second stage lights up and propels that second stage along with our Starlink satellites to orbit.
Got to see that little...
What a beautiful view of those 9 M1D engines burning there on beautiful clear day.
I can't get a word in today.
And we're coming up on main engine cutoff shortly here in just about 10 seconds.
Saw that supersonic pressure wave. That was pretty awesome. Right at max Q.
MECO.
Stage separation.
And recognition.
See the stiffener ring break off?
You can
right there?
see
There it
in that beautiful footage that we did just have MECO, stage separation, and second engine startup 1. Those grid fins are coming out on the first stage there on the left. And in just a few seconds, we should have our fairing deploy.
Fairing separation.
You heard the call out, and you can see on your video there that we have had successful fairing deploy. And again, today's flight marks the 40th time that SpaceX has reflown a Falcon fairing half since November of 2019. Now, this is also our first 5th reflight for one of our fairing halves and a 3rd for the other half. In order to recover these fairing halves for future flights, we will be attempting to recover them again with the help of our recovery vessels, Go Searcher and Go Navigator.
So they're going to soft land the fairings in the water, pluck them out of the water. No more nets. They're not doing the mischief net. They're not trying to catch them anymore. They're just going to soft land them and then pluck them out of the water. So at this point, right now, the booster is still climbing. So even though it's separated, it's still climbing.
Stage 2 continuing towards its first orbit on the right-hand side of your screen. Left-hand side of your screen, you can see Falcon 9's first stage reorienting itself for its next 2 activities. That'll be 2 burns to come back safely to Earth. First of those being the entry burn. That's where we'll ignite 3 of the Merlin 1D engines to help slow down the first stage as it re-enters the upper parts of the Earth's atmosphere. The second burn will happen closer to the drone ship. That's the landing burn. That's where we'll ignite just the single center Merlin engine. That'll bring the first stage's velocity rapidly down to 0 for a soft touchdown. On the right-hand side of your screen, second stage continuing to burn nominally, acceleration right down the middle. And you can see the glow of the nozzle there.
I saw both.
If you are just catching up with us, we did have a...
Stage 2 on nominal trajectory.
We did have a successful launch of Falcon 9 from Cape Canaveral Space Force Station. And first stage on the left-hand side of your screen is headed back to our drone ship named Just Read the Instructions, stationed out in the Atlantic Ocean. Second stage heading on the right-hand side of your screen is headed to its first orbit. As a reminder, today's mission does mark the 2nd flight for this booster. If you happen to catch fairing separation earlier, this will be the first 5th flight for one of those fairing halves and the 3rd flight for the other half. Reusability is critical to what we do here at SpaceX. It allows us to refly the most expensive parts of the rocket, and that drives down the cost.
Saw both.
You can see the grid fins extended on the left-hand side of your screen. Every so often, you'll see puffs of white gas. That's attitude control coming from the first stage to help reorient us to get the 9 Merlins on Falcon 9 pointed towards the Earth. Those Merlin engines are optimized for thrust at sea level, They help Falcon 9 achieve about 190,000 pounds of thrust during ascent and descent. Meanwhile, the Merlin vacuum is optimized for space. That's why it has that larger nozzle. Now, coming up here is entry burn. Keep an eye out on the left-hand side of your screen.
Stage 1 entry burn startup.
Stage 1 FTS is safe.
This burn expected to last about 20 seconds.
Saw both our Space Mouse and Space Caterpillar today. Talk about that after
Stage 1 entry burn shutdown.
second stage.
Successful shutdown of those 3 Merlin engines. Now, if you followed along our missions in the past, you'll know that soot
Stage
on
2
the first
continues on
stage
nominal trajectory.
is an indication that the rocket has flown before. That's because we use rocket-grade kerosene, or RP1, as our fuel in Falcon 9. That's a carbon-based propellant. As we burn it, it generates soot. So with the engines down, as we're coming in through the Earth's atmosphere, the soot from the plume comes back up on the first stage and deposits it along the surface of the vehicle.
Oh, looks like we lost the first stage camera. Go back
Now,
to
if we
first
didn't
stage.
do that entry burn, the first stage would come in very quickly in the atmosphere, and the aerodynamic forces could
Stage
cause
1
it to
is
rip apart.
transonic.
So that's why we do that entry burn.
Should get landing burn here coming up.
And we did temporarily lose the video feed, but we'll hopefully... There we go.
Oh,
Beautiful view. Now, at this point,
doesn't look
since
like the
we're
right
in
view.
the Earth's atmosphere, those grid fins will take over orientation and trajectory back towards the drone ship. Now, coming up, stage 1 landing burn will begin. Shortly after landing
Terminal
burn
guidance.
ends,
Landing burn startup.
the
Landing
second
burn.
stage's engine will shut down. We should be in our expected orbit there. So keep an eye out, see if we can get a video feedback for the first stage.
The telemetry for stage 1 has stopped as well. Oh, but that's all right.
Stage 1
Here we
landing
go.
leg deploy.
Here we go. Land it! Land it! Come on! Where is it?
Fantastic. Right down the middle. That's our 85th
Stage 1
successful
landing
recovery.
burn.
100th, 18th successful launch of the
Stage 2
Falcon 9.
FTS is safe.
Now keep an ear out here for second engine cutoff number 1 on the second stage.
Go.
And with that, navigation officer, we did hear the call out there for SECO. Navigation officer will be checking
Expected loss of signal.
the
Cape.
parameters. Make sure we are in our intended orbit.
Nominal orbit insertion.
Here it is.
Fantastic news. So from here, we do have a coast phase followed up by the second burn of our second stage engine. These additional burns allow us to modify the orbits of the payload more efficiently than if we were to launch directly into our final orbit. That's just one of those quirks of orbital mechanics. And today, our second stage will coast for 35 minutes until we reach apogee, which is the highest point of the orbit. Views here on your screen of the fairing and then the Merlin vacuum engine on the second stage. So once we reach the highest point of the orbit, we will reignite the second stage for a short burn. And you can follow along the progress of the second stage with this animation showing where we are around the Earth. We'll be back here at T plus 44 minutes and 30 seconds for second engine start number 2. See you soon.
All right, so we're in good shape. We're in our parking orbit here right now. Nominal orbit insertion. We've got a bit of a coast phase, so we're going to hang out for a bit, and we're going to get some Kerbal action on, of course, during the Starlink coast phase. But I do want to go back and replay a couple of things, because we had some pretty cool stuff that we saw here. So we've got what we're looking at. Somebody had mentioned that it's a shame that they can't reuse the second stage and the fairings. The fairings, they do reuse. So those will come back, they parachute back down, they'll scoop them out of the water, so no problem on the fairing. The second stage, I saw a bunch of people ask what happens to the second stage, all that kind of stuff. The second stage, they will deorbit the second stage. It's going to deorberate. The second stage is going to come back and burn up in the atmosphere. It doesn't, they can't recover it, it's going too fast, it doesn't have enough heat protection, doesn't have enough fuel to slow down to stop it from heating up so much, so it will do a deorbit burn. It's going to deorberate, and it's going to come back. It'll burn up in the atmosphere, usually off the western coast of Australia is where that will happen. So that's typically the idea. So All right, let's go back. We'll take a look here. So we were during the coast phase. I do want to take a little replay look at a couple things. The first thing I want to look at is that when she went supersonic, that was pretty awesome because we got to see the little supersonic pressure cloud there right as it went supersonic. It actually scared me for a minute because the guy came on the radio over the communications net there and said something right as that cloud happened. So it was like, oh, I thought something had happened, but it was good. It's all expected. So let's watch a replay.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicle is pitching downrange.
Love that sound. I could watch that. I could listen to that launch sound a million times. Then we get a great view roll program here.
Stage 1 propulsion is nominal.
Which is pretty awesome.
What a beautiful day for a rocket launch here.
I'm going to turn them down because they wouldn't let me talk on the first try around. So I'm going to turn them down and I'm going to talk over them this time. But watch this. Right at a minute and 12 is max Q. So right here you'll see the little pressure wave there when it goes supersonic. Right? Look at, you see a little bit forms a little bit, then whew, right there as soon as it goes supersonic. That was pretty awesome.
Passing through max Q here in just a few seconds.
Okay, so we're gonna fast forward a little. Well, actually, no, I'm not gonna fast forward quite yet because there was another cool view that I do want to see here. I love that. I love that view, like looking back at the engines. This one right here. I would love to see this for longer. All right, let's go. Before we get into, let's see. Well, I'll just take questions. We'll let this play, and I'll answer people's questions. In the meantime, let me scroll back. I'll grab a couple questions. Are we launching another one? Yeah, this is a replay. We are going to launch it. We're going to launch another one. They're not. Not yet, at least. Let's see. Deploy the landing leg, says Framrick. I feel like that's an attack on me. Thankfully, the first stage is separated successfully, not the same as Rocket Lab. Actually, Rocket Lab had a successful separation. It was the reignition of the second stage, or not reignition, the initial ignition of the second stage that went wrong. It ignited, and then they said something on the second stage. The second stage computer shut down the engine of the second stage because it detected some sort of anomaly. There's separation. You see our little stiffener ring right over here. Break off the engine bell right after ignition. Right there. There it goes. See you later. Don't need that anymore. Just keeps that engine bell nice and rigid inside the interstage. Let's see. Seem to be a lot of debris below the first stage. Yeah, well, I'm going to show that here in just a minute. It's all pretty much ice and solidified oxygen. There's our payload fairing separation. May even see on the left camera, you see the payload fairing. It's on the right camera. Sorry, I mean the right camera. Right there is the payload fairing. Just on the left of the engine bell in the right camera. And there's one of our space caterpillars. Let me back that up just a touch. Right here. Here's our space caterpillar. We call that the space caterpillar. This is really just solidified oxygen here. So they do something called engine chill. I'm going to back up a whole bunch here. They do something called engine chill before they start up the second stage, where they flow super cold liquid oxygen through the engine to cool everything down so they don't shock the system. They try to gradually chill everything down. And that means that there's oxygen in their systems there. And if you look right here, these are the oxygen vent lines from the engines out the side of the interstage. So oxygen is going to flow out this direction. This is on the interstage here. We'll see a separation during. Let me back that up one more time. During separation, those hoses also separate from the first stage. You can see you can kind of see here's the hoses right here going with the first stage and the interstage. They separate from up here and carry on. But now in that little hose, there's a tiny little bit of liquid oxygen still in there. And so when we see that space caterpillar is what we call it, that kind of comes out the side there. We call it the caterpillar because sometimes it's like, as it comes through, as it comes out of it, it's like partially solidified, but not completely yet because it was in liquid form. So sometimes it's got a little bit of flex to it, but it vents out. That vent port is now right here from this camera view. There's the vent port on that first stage where those hoses connect. And so that's where we see a lot of that come out. Let's see. There you go. So there's the caterpillar floating away right there. I think we also saw a second one a little bit later. So you just get little bits and pieces of that. Also, don't forget, you got warm, humid Florida air touching that super cold negative 340 degree rocket skin. You're gonna get condensation that freezes on the outside, makes ice on the outside. So a lot of that breaks off as well. We'll see. We got a couple of occurrences of our space mice right here. Again, same kind of idea. There's a liquid oxygen vent port. We just saw them, the same ones I was just talking about with the hoses. Now those are uncovered, and they can vent directly into space. Well, sometimes some of that liquid oxygen solidifies, then it breaks off, and it gets caught on this gigantic pipe right here. So occasionally you'll see here's a little bit collecting right down here. The vent hoses are up here, so generally it's gonna solidify here, and then it breaks off right there. So this is a different view. So I think this is the hoses from this view. Breaks off here, gets stuck on the engine bell, and then it can sometimes crawl along this pipe here. And a lot of conspiracy theorists think that that's evidence of a mouse. It's the most consistent mouse I've ever seen. Like, it's a very well-trained mouse. Because it does it on every single launch, almost. So, I don't know what mouse you could train to do that exact same maneuver every launch, but the conspiracy theorists will tell you that this is all faked, and it's proof because there's a mouse right there. Which I don't understand that logic, but at all. How come the second stage burns much longer than the booster, even though it has much less fuel? Well, you also have 9 engines all burning on the first stage, so it's burning a lot. You're burning a lot more fuel faster. First stage or the second stage only has 1 engine there, so yeah, a lot more fuel consumption on that first stage. Wouldn't it be better if Starship had legs like the Falcon 9? Yeah, Starship definitely has a leg problem, and it is something that they're working on improving, is the Starship legs. But every time, the problem is, like, you add big thick legs to handle a landing better. Now you just added more weight, and now there's less that you can take to orbit because of that. How do the fairings make soft landing with parachutes? Yes, they do have steerable parachutes on board, and yes, they will parachute into the water. When the second stage ignites, there's a collar that comes off the end of the nozzle. What is that for? That is the stiffener ring that holds the engine bell nice and rigid while it's inside the interstage, and it intentionally breaks off when the second stage ignites. So yeah, that's called the stiffener ring there. It's just I think it's a cork stiffener ring. We'll get to, we're going to watch the landing here, and then we're going to try to fly some rockets of our own. The trained NASA mouse, yeah, right?
Now, if we didn't do that entry burn, the first stage would come in very quickly in the atmosphere, and the aerodynamic forces could cause it to rip apart.
Starship doesn't need legs. They plan to catch it. Yeah, so they have talked about, he has talked about catching it with the launch tower, which I'm still kind of on the fence of, like, is that really going to happen? And what they had talked about with catching with the launch tower was the first stage, because they had talked about using like the grid fins to catch the first stage on the tower itself. I don't know if Elon has mentioned catching the second stage, which is the actual Starship, but he's definitely talked about the first stage, catching that with the tower. That would be the super heavy booster. The second stage, the Starship, as far as I know, they're still going to try to land it with legs, but it wouldn't surprise me if they also tried to catch that as well.
Fantastic. Right down the middle. That's our 85th successful recovery. 100th, 18th successful launch of the Falcon 9. Now keep an ear out here for second engine cutoff number 1 on the second stage. And with that, navigation officer, we did hear the call out there for SECO. Navigation officer will be checking.
Expected loss of signal.
Let's see. Digital Nomad on Fire podcast says, find me some conspiracy theorists that say that. It doesn't seem real. You can just go back to my YouTube videos. Go back to like the Demo 2 YouTube video, because that's where the theory first showed up. It was on the Demo 2 launch, and then the launch after that. I forget which one was right after it, but it started on the Demo 2 launch because a bunch of people that don't watch Falcon 9 launches tuned in for the first time for the Demo 2 mission, the first time that we flew astronauts on the Crew Dragon capsule. So this is the first time that a lot of people had watched a Falcon 9 launch, and so they'd watched the Falcon 9 and they saw what they thought was a mouse, and that's why they said that the astronauts didn't really go to space. So yeah, if you want evidence of the conspiracy theories, you just go back and look at Demo 2 mission, because we had a lot of them that day. Let's see. All right, well, let's go. Let's go launch our own rocket, because we've still got quite a while. Let's see, what are we at? 24 minutes. The actual deployment is at about 1 hour and 3 minutes. So we've got like 30, what is that? 37, 38 minutes or so to wait here for deployment. So in the meantime, we should launch our own rocket. We just have to figure out what we want to launch today. Let's see, I gotta switch over. All right, let's go back to, let me go to here, get this back to live. Now the question is gonna be, is my clock still on? No. See, anytime I go back and do replays, it messes up the clock. Thanks to YouTube streaming and buffering. So let's see, what do we, we're 8 seconds ahead. That's quite a bit, actually. Let's see if we can get this lined up here again, so we can be on the same path. Oh, nope, too far. Let's see. Here, maybe? Let's try this. Does this line us up? Almost. We're so close. All right, that's close enough for me. Close enough. Now we got the clock lined up. Now let's fly. Try catching a rocket. Try catching a rocket with a catch tower. That could be interesting. If anyone can land Starship, it's you. Wow. That is putting way too much confidence in me here. Oh, I went to this because I needed to mute that so that I can turn this up. Just blame the clock differences on relativity. That's what it is. That's the problem.
Space Lobster ate the T-Tab. That's the answer.
That's the answer. That's the answer, Tim. Congratulations to Tim Dodd, the Everyday Astronaut, too, who just reached 1 million subscribers on YouTube. That's pretty awesome. All right, we want... Let's see. What do we want? Where are all my... There we are. Here's our... This is the Falcon 9, right? I believe. Oh, yeah, there. Oh, with the tower. Falcon 9 with the full... This Crew Dragon with the launch tower. Look at that. That looks pretty sweet. I did not build this. This is the Tundra Exploration Pack. I didn't know we had this. This is kind of cool. Let's launch this thing. Maybe we'll try to land the first stage too, maybe. Let's do it. Don't fly. Monkey DKS says, don't fly a Falcon 9. Remember what happened with Rocket Lab. You have no confidence in me. I got this. Probably not, but we'll see. I'm just excited for the launch tower there. Excited to see
American astronauts on American rockets from American soil.
Right? All right, let's go. Look at this. With the tower and everything. This is kind of cool. Let's check the staging here first. So we got that, and then that goes, and then that, and then that. How does this thing activate? Let's see, does it not do anything? Maybe it's just for looks. Does it do anything if I click on that? Arm and status locked. Let's see, hold on. Move up. I can't. Oh, yeah, all right. If we do that, oh, what's happening? It's going away. Well, that was interesting. Well, I hope they don't need to get off anymore. Let's see. Arm and interface adjust. That's kind of cool. We can retract the arm. Like that. Which is what they would do for launch, except they don't go all the way back for launch. So, for launching the actual crew, they stop about halfway to get it out of the way of the launch abort system. So generally they stop right... Oh wait, I can do it manually. They stop right there. And then at launch, this will go all the way back. Which is kind of cool, actually. That I can do that manually. Yep. We'll retract it. All right, let's get a Crew Dragon into orbit. Let's see. This is Space Lobster Mission Control. Astronauts, make sure your visors are closed and locked. We're getting ready for launch. Let's see. We could even do it like an abort test. That would be kind of cool, but... I think we'll just do a regular launch. You should have read the manual. We've got no chance. All right. Stand by for terminal count. Here we go. 5, 4, 3. Ignition. Okay. Nothing happened. Okay. Redo. 5, 4, 3. Oh, okay. Well, we are separated from the tower. Why didn't the engines ignite? Oh man. Come on. All right, we're all the way up. Well, it's not even a static fire. Yep. Oh no! Abort! 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 Abort action! Oh no. I'm sure they're fine. Yeah, we're good. That was a good thing this was an uncrewed test. Ow. I don't know what happened there. All right, redo. Revert flight. Back to launch. Well, that was not quite as I planned, but it was a nice little test there. Okay. I'll put myself over here. Because my game is on this monitor here, and if I'm in the other corner and I'm looking this way, it looks like I'm looking off the screen, which is weird. Okay. Let's see. What exactly happened? 5, 4, 3. I have no engines. Why do I have no engines? Oh. That seems like a problem. I'm just checking what the keys I'll do. Why didn't it? How come our engines didn't activate? We're being held up right now by the tower. Okay. Well, toggle soot. Switch mode on flameout. Give it next engine, previous engine. No. Gimbal locked. Free. What is happening? The engines should be on. Go. Okay. How about an abort? Can we abort? Abort action. No, even the abort engines aren't going. Why? Why won't you go? Well, is there fuel? There should be. That's a good question, though. Yeah, monopropellant. Oh, I'm all separated here now. Huh. Maybe this is unlaunchable. Okay. Read the manual. Sorry. We don't need a manual. We got this. This is for anybody doubting my skills here. This is an add-on for Kerbal Space Program. So occasionally, I suppose it may. I don't know. I'm not sure what is happening with. Here, let's retract the launch tower. Get that out of here. Let me get some of this stuff out of here. Close some of these things. Get rid of that. Do I need... Oh, maybe we need... Let's go back to vehicle set. Maybe we need astronauts. We shouldn't, though, because we're right at the Space Center. But maybe we need a pilot. Let's put some crew in. Let's risk lives. So we definitely need a pilot and an engineer and a scientist and a scientist. Okay. Leave facility. Empty seat. Assign the no, your first seat's the pilot, then the engineer, then the scientist, and the scientist. Okay. Let's try that. Senate cut funding. You need to clear the pad? Is there something on the pad? Your lobster cut the fuel line. That's probably
Space lobster ate the T-tab. That's the answer.
That's the answer. That's the problem. Okay. Got nothing here. We're good. Go like this. Retract this arm. 5, 4, 3. Who's got a lighter? Ignition! Ignition. Ignition. Alright, guys. We have a problem here. Oh! 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 Something's happening! Lift off! Something's happening! Not all the engines are on, though, I don't think. It's alive! It's flying! Okay, well, that's weird, but... Alright. I don't know why that would be. What did you do? I don't know. I don't know. Wish I knew. Alright, we need to... Let's see. Roll program, and we're gonna go... Oh, actually, I don't want to... yeah, we'll roll. Roll. We're gonna pitch this way. Oh, we should have went polar orbit so that we could land the booster. Oh, too late now. Now I need all my displays back. Get my HUD, my orbital display. Okay, we're good. We got this. Coming up on separation. And let's see if the next engine will work. Shutdown. Separation. Uh-oh. Oh, boy. Well, there goes our... Yeah, why are these engines... Activate. Activate. Activate engine. There goes the landing attempt. Yeah. What? Something weird going on. Cause, oh, here you go, right here. It says status flame out. Cause oxidizer deprived. Why am I deprived of oxidizer? Somebody look that up. Why? Why would I be oxidizer deprived? Can I just turn off flame out so that this stops happening? Can we cheat? Unbreakable joints, ignore max activity, hack gravity, that's kind of cool. Part clipping, not strip biome visible, pause on vehicle impact, infinite propellant, infinite electricity, ignore max temperature. No, okay. Ignore agency mindset, allow stock vessels, lost crew respawn, allow revert to launch, allow revert. Okay. You say, okay, well, Show all log errors on screen. Well, we have a flame out. At least I know the answer this time. Try infinite propellant. Infinite propellant. Oh, that worked. Interestingly. Why would that work? I got plenty of oxidizer. Now we're gonna crash, though. Alright, well, we're gonna do that. Aerodynamic forces overlay. No, I don't want that. I want... Nope. Okay. Might have something to do with that little collision. Yeah, all right. We're going to try this. We're going to try it one more time. And this way we can go north, too. So, I need to make sure, I guess, to start with, how do I know? We're still got infinite propellant. How do I know which engines are active down here? Oh, here you go, right up at the top. All engines, 3 landing burns, center engine, all engines. Okay. Ready to go. All right, I think... All right, I'm feeling good. I'm feeling good. I got you. All right, here we go. Place your bets. This is Mushy Magazine. Here we go. Retract this thing. Kerbals, close and lock your visors. We're going to go again. Thank you. Here we go. You know what we also... You know what the problem was? I know what the problem was. The problem was we didn't have our pump-up jams going. That's what we need. Here we go. Now it's time to fly. Oh, except they're about to do, they're about to restart the second stage for Starlink. That's alright. So we got a second stage restart coming up here in just a couple seconds. So I'm going to do this first. We'll watch this. It's only a 1 second relight to circularize the orbit. And then we'll go back to flying Kerbal. Should be coming up in like 1 minute here. I got $10 on the rocket. It says Southern. Don't light it.
Starlink mission. We had an on-time liftoff at 2:59 p.m. Eastern Time from Slick 40 at Cape Canaveral Space Force Station. Second stage continues to look good, and our second engine startup 2 is just a few moments away here at T plus 45 minutes and 30 seconds. Now this will be a very short burn, only 1.58 seconds of our MVAC engine that you can see on your screen there, and this will help us get into a more circular orbit for our Starlink deploy. Hopefully we can catch that really quick burn on video. Now before this small burn, we have been pulsing the settling thrusters on our stage 2 to keep the propellant at the bottom of the tanks, ready to be pulled into the engine pump when it spins up here in just a few seconds.
This should be it right here. Restart and shut down.
Again, we're just waiting for acquisition of signal from our ground station.
So we might have missed it, but sometimes the video feed is delayed, so sometimes we can still see the video after it's maybe already happened. Oh, there it is. Yeah. And done.
S2 burn 2 complete.
Good burn. Looks like the video came back just in time for us to see that burn there. And now we're just looking for a confirmation of a good orbit.
Nominal orbit insertion.
There we
You
go.
heard the
Good
call
to go.
out for the nominal orbit. We have another coast phase coming up here before we deploy our next batch of Starlink satellites into orbit. During this time, the spacecraft will start to spin along its central axis, giving the Starlink satellites the momentum they need to space themselves out over time after they deploy. We'll see you back here at around T+1 hour and 2 minutes.
So just to give you an idea, here's our Kerbal animation from a time when maybe I kind of knew what I was doing. Just to show you what the actual that second stage is going to do. So it's going to spin around its around the axis here to get some differential speeds there on the satellites. Then it's going to let them go. It doesn't push them away, and it's going they will just spread themselves out because they will be traveling slightly different speeds because of that little circular spin there. So that's what we're looking for deployment. But before we get to that, first we need to go back to our Kerbals because they're waiting in a holding pattern, and we're gonna try this out here. We're gonna see if we can launch. This one. All right, here we go. T-minus 5, 4. We'll see if this works. 3, ignition. 2, come on. There we go. 3, 2, 1. Lift off. All right. The clock is running. We've cleared the tower. One Alpha. Roll program. Vehicle's pitching downrange. Come on, baby. We got this time. Oh, they're pitching a little much. We've been a little hard over. Max Q. It's probably a little early for Max Q. Max Q is like 10 kilometers. Oh, we're drifting. Why are we drifting? We're drifting. What's happening? Oh, 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 oh. Get our RCS here. RCS, get us back on track. It's alright, we're okay. We're alright. We're past Max Q. Oh, oh boy. Oh, okay. Cut off. Separation. Yep, and spin maneuver. And just like they do it in real life. Okay. Oh, we're great. Golden. Good to go. No problems here. Oh boy. Wow, it is so hard to control. What is happening? Oh, this is a problem. Oh, this is definitely a problem. No, 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 no. Wow. It does not want to fly right. Where are you going? Where are you going? Oh, oh no. Oh no. Oh no. Yeah, I think that's gonna be an abort. So, all right, send them. Let's see. Decouple. Retrograde. I don't know what happened. All right, well, this is a demonstration of the abort capabilities. Okay. Well, we didn't get very far. Oh, man. We're gonna save the astronauts, at least. Is that really how they do it, though? Are you doubting me? Are you saying that's not how they do it? Oh, there goes our second stage. Alright, at least we got some parachutes. Hey guys, let's just check in with you here. How's everybody doing? We'll check, how we doing in here? Let's look around. You got a pretty bare console. But, hey, these guys are cool. They're good. No big deal. What's up, man? We're good. Yeah, we're fine. All good. Oh, he's waving me off. He's saying, no, we're not. No, no. Oh, geez. All right. All right. Oh, where's the first stage? Can we still land it? Yeah, maybe. Where is the first stage? Cannot switch vessels while in atmosphere. No, too late. Well, we saved the astronauts. Let's fast forward to a nice soft touchdown. Your Kerbals look horrified by what just happened. I know, right? They look slightly annoyed. Well, oh, jeez. I think that was the first stage. I don't think the first stage made it. Here we go. 70 meters, 60 meters, 50, 40, 30, 20, 15, 10, 5, touchdown. Okay. They survived. All right, we gotta get this. Why am I having such a hard time with this? I think the oh yeah, you might be right. That last explosion might have been the trunk. I think you're right. Okay. We got this time. So we're gonna go, let's see, engines up, like this. Which engines? Current mode. Oh. All engines running. 3, 2, 1. Lift off. Turn off the infinite fuel. Oh, we can do that. Alright, let's try this again. Roll program. Let's get a little higher in the atmosphere before we pitch over. 1 Alpha, roll program. Vehicle's pitching downrange. There's max Q. Oh boy. Oh, she's already getting tough to control. She's drifting. The atmosphere. That's good. Gonna pitch over. Go. Shutdown. Separation. Ignition. It says I have no fuel. I don't know why that is. Why it says I have no fuel, I don't know. Shut down engine? No. Activate engine. Activate. Oh, here we go. We're good. I got it. Oh, you're gonna need that infinite propellant for some reason. I don't know why it won't run without infinite propellant. All right, let's get this guy into orbit. Now we gotta go horizontal. Here we go. Oh boy. Oh, yeah. Oh, all right. She doesn't want to go the way I'm telling her to go because we're still in the atmosphere a little bit. Okay. All right. Easy. Easy does it. Here we go. Go this way. Pitch down. There it is. Okay. All right. Easy. Come on. Stay right there. Right there. Easy does it. Oh, I got the wrong guidance mode. That's why it doesn't want to pitch where I'm telling it to go. Trying to get that horizontal velocity in. We're good. We're good. All right, here we go. Polar orbit, here we come. Look at our Kerbals. They're loving it now. They're loving it. We're good. We got this. We got this, Kerbals. Come on. Get us into polar orbit. Almost there. Boom. In orbit. All right. That's in orbit. Now let's go back. Can we land the first stage? Switch to. Okay, you better go retrograde. Let's get our grid fins. Grid fins. Grid fins out. What's the shortcut for grid fins? B for brake. That's it. Okay, got it. Grid fins are out. RCS. Flip it around. Hurry! Hurry! Flip it around! Oh, no! Oh, we're in trouble. Yep, flip! Flip! Retrograde! Retrograde! Come on! Oh, this is what we call the dive bomb maneuver. And yeah, can't activate the engines. Well, expendable mission. Okay, well, guess we're not gonna land that one. Our Kerbals are okay though. Why can't I switch to them? I got nothing will happen. Switch to... I guess I gotta go to the tracking station. Won't let me switch. You need the flamey end down. Yeah, that was a bit of a problem. Touchdown. Yeah, something like that. How close are we? We're 2 minutes from deployment. We got this. Loading. Oh, no. Not respond. Okay, we're good. All right, well, at least these guys are in orbit. These guys are all good. Now we can... What's our orbit? We're 109 by 91. That's okay. Here, we can even separate. Look at this. And Crew Dragon can fly free. Let's open the nose cone. How do we open the nose cone? Nose cone. Let's see. We can turn the lights on. We can open the nose cone. There we go. Good to go. I don't need this anymore. How do I get this to go away? Go away. Go away. I feel like this is not responding to my key combinations. There we go. I wonder if all this trouble that I have, I wonder if like OBS is reserving one of these key combinations that I keep trying to use. I don't know. That would be interesting to find out. There's got to be somebody else that streams Kerbal and OBS at the same time. Oh, they're back.
Second stage Merlin vacuum engine startups. So we had some video shots there of the second stage. We're awaiting our next major event, which will be payload deployment of the Starlink satellites. Now, over the last coast phase, we've started to spin the second stage a little bit. You can actually see maybe the sun might pop into frame there. And that's to help those Starlink satellites space themselves out after payload deployment. And here's a shot of the top of the second stage, camera looking up at the Starlink satellites.
You can see that shadow moving, and that's because it's spinning like this. Spinning sideways, basically. That. Oh, you can even see the... Is that the
so coming up, payload deployment.
Should be pretty much right now. See a little pin right here, right there. It's pulling out right now. That pin comes out right now. Way it goes.
Deploy confirmed.
There they go.
So that's confirmation of payload deployment. You saw the mechanism separating away, and now the Starlink satellites starting to make their way away from the second stage. Shortly, they will deploy their solar array. Wow, that's a beautiful shot cool. Of Earthrise in the background. But shortly, they will deploy their solar array, and then over the next few days and weeks, they'll start to distance themselves out. They've got onboard ion thrusters, and that'll help them make their way into their final operational orbit.
And with that successful deployment of our satellites, we'll bring today's webcast to a close. Thank you to the Range and Federal Aviation Administration for supporting today's mission. And of course, thank you to all of our viewers and all of our Starlink customers using our beta service at this time. If you're interested in being a part of our beta program, head over to starlink.com and sign up. Hope you enjoyed the webcast today, and we'll see you soon.
All right, away they go. And we're going to go back to... Kerbal. Because I am determined to figure this out. Right? We need to get... Let's see, should I put myself... I'll probably put myself over here, then you guys can see the faces of the Kerbals. We need to... Okay. We're going back to the Space Center. We need to land one of these Falcon 9s. This is ridiculous. I'm landing one. I gotta try. I don't know. I don't have much time because I actually do have to finish my regular work for today. But Let's see. Get the FMRS mod to land the first stage. I had the FMRS mod for the first stage, but it's technically not compatible with the new versions of Kerbal. And I haven't dared to try installing incompatible plugins. But I probably should. Probably should give it a shot. Kenneth Otto says, "You can do it!" Come on. All right, we got this. I gotta be able to do this. We gotta have this. Let's see. Tundra Mothra 1 MLP. What's this? Oh, that's Falcon 1. That's what that is. Maybe we should just fly Falcon Heavy. That way I have multiple chances to land the boosters. This doesn't have the tower though, which is not as interesting looking, but it's alright. We could fly Falcon Heavy. Let's fly Falcon Heavy. Let's do that. What happened to Falcon 1? Falcon 1, that was the original SpaceX launch vehicle that they did 4 launches of. First 3 that failed, and the 4th one that worked. Do they have an autopilot? There is an autopilot mod that you can add to it, which I do have installed here. But for some reason, this mod for the actual like Falcon 9 doesn't like me for some reason. I don't know why. I don't know. We're gonna try it here. Let's see what we can do. Let's get rid of some of these windows that I have open because we don't need them all. Okay. Here we go. Falcon Heavy. In 3, 2. It's gonna do the same thing again. Come on. Why are we current mode? Center only, all engines. Why do I have to manually activate these? Oh, now we're talking. Okay, 3, 2, 1. Lift off. Clear the tower. One Alpha, mode roll program. Padre for the reminder to turn off infinite propellant. Vehicle's pitching downrange. There's Max Q. Center core throttle down. Oops, I meant to shut those off before I jettison those. Well. I guess we'll have extra time to land those boosters. Because those are, actually, they're going to be out of fuel, so that's going to be a problem, but... Throttle up. Okay, well... Alright, and let's go... Side boosters to the universe. Yeah, they're gone. All right, shut down. Separate. See, it still says I have 0 fuel. Why is that? Okay. Fairings. Didn't mean to do that. Engine activate. Good to go. Okay. Now we're flying. Shot the boosters to the moon. Yeah, they're gone. Yeah, that is improper staging. Yep. Well, that's a problem. That is improper staging. There we go. We got this. Let's just get it into orbit. Get it into a stable orbit. We'll shut down. And we'll try to land something. Okay, shut down. Got it. Where did our boosters go? Man, those just... Oh, there they are. Yeah, they just... Look at those 2 boosters. They are out of here. They're still... is their velocity's decreasing now, so they must be out of fuel at this point. Well, I got lots of time to land those. Let's switch... I guess we're going to do the center core first. The boosters are... Their boosters are going out to visit the lunar gateway first. All right, retroactive. There we go. All right, grid fins out. We got this. All right. We're good. Now, should we do infinite propellant? Okay, we have infinite propellant on. We want... I'm gonna leave this open so that I can, if something goes wrong, I can see what the problem is. Hopefully. What's quick save? 5? F5? F9? There we go. F5, quick save. All right, we saved it. You know what we should, go here. Then I'm gonna pull up my super top secret landing guidance and maybe that'll help us. All right, let's do an entry burn. We'll test it out, see if it works. Okay, it works. Good news. Where is it going to land? Preferably not in the mountains. We don't want to land in the mountains. Let's bring it in. Bring it in. Easy does it. Let's land right in this little valley here. That would be nice. Okay. Okay. Okay, now we're going to switch to our 3-engine entry burn. That was just that was like a boost back burn there. Partial boost back burn that we just did. We're gonna try to land in this valley. We're targeting here somewhere. Landing legs towards the ground. Good so far. Yep. Here, let's quick save again. Okay, so far so good. Still coming in kind of hot. Getting some heating. Here's where we'll do our... Whoa, easy. 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 Entry burn, so we don't heat up. 3-engine entry burn. Bring it home. There we go. Oh, just like the real thing. Look at this. There we go. Then we're going to do a center engine only. Center engine only landing. Need our Kerbal engineer, our landing HUD, so we know when we're supposed to start the landing burn. Okay. So far so good. Grid fins. Easy. How many? Suicide burn count to... Uh-oh. 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 Oh, no. Nope. 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 Problem. Problem. Oh, problem. Oh! Why won't those engines relight? I don't understand. Okay, let's do this again. 3-engine landing burn. Or this is our entry burn. I think we're going to have to do a 3-engine landing burn because I have infinite propellant on, so I still have a lot of fuel in the tank. Okay, let's try this again. Let's see if it'll actually... if the engines will actually reignite. Okay, 10 seconds to the suicide burn. Oh, see? Like, they just flame out. We flamed out already. Like, they're supposed to... it says they're on right now. I can't raise the throttle. Why? Why won't you put the throttle up? Throttle up! I don't understand. I need to figure this out. Alright, last attempt. And I'm gonna like... what are we on? 3-engine burn? Yeah, okay. I'm gonna try to keep the engines on the whole time. We're just gonna bring it all the way in under power. I think we fixed it with unlimited fuel, but I have unlimited fuel. It's on. It's still just like, if it's over, it's something about the speed, because if it's over a certain speed, those engines, at least on this Falcon 9 model, if it's over a certain speed, those engines will not ignite. Oh, and I am definitely burning in the wrong direction. It's a slight problem. Like, if it's over, like, when it gets into the atmosphere, like it's below a certain altitude and at a certain speed, those engines will flame out. So that's why I'm trying to, like, keep it going, but I need to figure out how to change that, because that is really annoying. It's like right around 100 meters per second, I believe. Are you sure only 3 engines are lit? Yes. Looks like more, but yeah, it's only 3 engines right now. Just the center 3 engines are lit at the moment. We're coming in nice and slow. Underpowered flight the whole time. We're gonna land in this patch of trees. That'll be good. So, all right, while this is coming in, somebody watch the screen for me. Tell me when it's time to land. Let's see, Tundra, engines. Let's see, we should probably start with Kerbal, Tundra, engines, won't ignite in atmosphere. An atmosphere above 100 meters per second. I don't see anything. I got nothing. I don't understand. Oh boy. Oh boy. Ignite! 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 There we go. Oh! Oh, she came in, she came in a little hot. But that was better. That was better. Alright, what time is it? Alright, I feel like I say this every time. I'm gonna work on this. I need to figure this out. She came in a little hot. That was closer. But I gotta go finish some work up, do some regular work, but we'll be back again probably next week for the CRS mission coming up, I think is the next thing that's coming up. So we'll be back again. Hopefully, maybe I'll try to get some practice in. Maybe we'll do that with some of our Patreon members this weekend or something. Try to get some practice in. See if I can figure out what the problem is. So, all right. Well, I can get better. I'll try to get better. Who am I kidding? That's half the fun part, is the fact that I can't fly. All right. Well, that's it. Successful deployment of the Starlink satellites, and very unsuccessful Falcon 9 landing for me. So we'll try again another day, and maybe I can do better, but no promises. All right. Well, that's it for me, everybody. Thanks for hanging out for a bit. I'll see you next time. Consider joining our Discord, and we'll continue the conversation there. And maybe for our Patreon and YouTube channel members, we'll I think maybe this weekend I'll try to figure this out and get better. I think I can do that. All right, thanks everybody for hanging out. My name's Tori. This is Overlook Horizon. I'll see you next time. Goodbye, everybody.
Woo!